Hello and welcome everyone. We're here in very sunny Portugal, and we are about to get ready to launch a rocket. It's µHoubolt, our bi-liquid propelled rocket with ethanol and pressure liquefied nitrous oxide as propellants. And we are currently, as you can see, we're at fueling. Ah. No, okay, I think we're at rocket mounting. We might already be at fueling. We don't actually know here. Let me quickly check if... Okay, we don't see the cameras. Anyways, we're currently preparing for the launch. Our launch window starts at... Let's blend that in. Our launch window is in 6 minutes. It starts in 6 minutes, so it's about to get interesting. We should be able to... Oh no, that's not the transition I wanted. There. We have our launch window now. We probably won't be able to launch like directly at the launch window because we still need to get clearance for actually filling the oxidizer. But apart from that, we should be ready to mostly go very soon afterwards. So I'd expect somewhere around 16:15 or 16:20. Of course, with the possibility for delays because it's literally rocket science. And before we continue elsewhere, let's quickly show you around the premises. There we are. No, not quite yet. We want these transition. There we are. Okay, so basically we have here our small streaming setup with our computers and everything. And in here is our mission control tent. Say hello, guys. And there you can see mission control. And in the back, we have a bunch of people, other rocket teams and bystanders that are just like viewing. And yeah, it's quite the interesting space here. It's also very sunny and hot. So we made sure to put on sun protection quite a lot. And yeah, to my left. Okay, got just called away. Yeah, to my left, it's Paula. She's helping with the stream, and I'm Lewis. And I guess let's go away from our faces and let's actually go to our overview. Let's transition over there. Yes, wonderful. Yeah, we have a tentative launch window, 16 to 1700 local time. You see, the local time is wrong, isn't it? Oh my God, it's not local time. It's actually, let's quickly fix the local time. We forgot to, since it's another time zone, we didn't update the time on the laptop, and now obviously it's not local time anymore, but it's Austria time. Okay, now the local time should be right. Did I just see... Oh no, the cameras seem to not be working. Let's quickly fix them, hopefully. Okay, so you can see that the pad crew is currently getting ready. They've installed the oxidizer bottle, and yeah, I guess I'll update you as soon as we get more information from Mission Control. They're just on the other side of the tent, so hopefully we will be able to get updates as soon as possible. But pretty much in the top left you can see the checklist. We've already done the electronics check earlier today. We've had a delay on our launch window. We initially intended to launch at 1400 local time. And we haven't been able to make that. It was just a bit too close to comfort. Like, we probably could have done it, but it would have been very like quick setup and everything, and we didn't want to risk all these years of work and the last 3.5 months of rebuilding that rocket after our not quite so successful test flight. So we just said, okay, no, let's go for the next launch window and let's just be sure that this will work out. Okay, I'm seeing people are putting on the long sleeve shirts and most likely the rest of the personal protective equipment. This means that we'll soon start fueling the ethanol. Oh no, we're actually doing the ethanol fueling already. um, you can see the basically a big syringe that's hanging on the rocket, and we basically fuel our ethanol, our main propellant, through the syringe. Basically, we have a small tire valve in there, and we just press in about 900 milliliters of ethanol into our ethanol tank. And with nitrous oxides, the problem is if you handle it, it may happen that basically if there's any spills or something and it gets on your skin, you can really quickly get frostburn, and it's really not good. So we always wear long sleeve clothing and protective equipment when handling nitrous oxide. So you will see two of the pad crew, the ones that will remain on the pad, to actually wear protective equipment for this. Okay, so on your screen you see to the right a bit of sparkly blankets basically. These are space blankets, and we have wrapped our server rack, which you see right in the bottom right corner. Then our nitrogen bottle, which is in the middle, the bottom middle, and the nitrous oxide bottle, or rather the water cooling mantle for the nitrous oxide bottle, which is the basically the pipe in the middle of the right frame with the masking tape around it. And of course our rocket as well gets a space blanket, um, simply because Portugal is incredibly sunny and hot and we don't want any of our components to overheat. So that's why we wrap them in these space blankets, which are very reflective and are rather good at keeping heat out. This way we can ensure that our server doesn't overheat, that our nitrous oxide doesn't go super critical, which would be bad, and that our rocket electronics and everything are just completely fine and in working order. Um, and now let's actually switch over to the other view. Yeah, that's right. Here we see the PNID, the piping and instrumentation diagram to the right. Um, this basically is our internal user interface. We don't see everything of the user interface. We have a few more tabs, and like we can press on things and get pop-ups and everything. But basically this is how we see and monitor the rockets in mission control, and basically also how we control it. You can see that the three-way valves to the right are currently set to the the cooling cycle, with the cooling pump being on. This basically means that we are cooling the nitrous oxide bottle, which will bring down the vapor pressure of the gas phase in the nitrous oxide bottle down, and this allows us to more safely open up the tanking procedure and start tanking. Um, to do that, we basically first pre-pressurize our tanks in the rocket to a pressure of around 30 bars. This will help equalize the pressures a bit and already like pre-fill the tank. And at this point, we will start opening up the tanking valve, which is seen at the bottom middle. You will see it when it opens up. And this tanking valve basically opens up the on the way from the oxidizer source bottle, so the nitrous oxide bottle in the cylinder that you see in the bottom left frame, and connects it to our tank. Then in there we have a solenoid valve that periodically opens. It's basically pressure controlled, so every time the pressure inside the oxidizer tank goes too high, we let off some of the pressure, which is basically releasing some of the gaseous phase of the nitrous oxide in the tank, which cools the tank down, recondenses some of the gas in there, and release pressure, and basically makes space for more liquid. And we want to fly with liquids and not with gases, so this is basically what we want. And yeah, that's basically kind of the process for tanking our oxidizer. Oh yeah, right. Of course, when we start tanking, we also switch over to the heating cycle, which in this case is not actually heated because it's already so warm. We don't actually need to put in any extra heat. It's fine enough with just the ambient heat here. So this basically allows us to tank faster, because when we tank the nitrous oxide from the source bottle to our tank, it basically cools down the bottle of the source bottle by tanking, and this makes it harder for anything else to go through. And so we basically have to like help it along and heat it up again to make more nitrous oxide go over. So that's basically the gist of tanking, at least the oxidizer. Are we actually already done with fueling? That's the question.
Yes, we're already done, and I think they just installed the igniters and are mounting the
Wonderful. I guess then we go for oxidizing prep then. Because in the chat, you have asked what kind of quick disconnects we use. Pretty much we use Chinesium quick disconnects. We actually had an issue with this, it was yesterday evening, where we did the final prep for the rockets in our paddocks, basically in the preparation area of the EuRoC. And the issue was that we more or less couldn't disconnect one of the, oh, we're getting some applause. Not sure for what exactly, but there's applause in the background. basically we tried disconnecting it and it didn't work, and the solution was to swap around two of them, and suddenly it worked again because the tolerances are so miserable. So yeah, it's just like, I don't know, random run-of-the-mill quick disconnects. I don't actually know for sure because I'm not in the mechanics team, so I don't know exactly. I've just done the software and know the rough outline of how the rest works. Actually, let's switch over to the other cameras again, because there we can see them connecting the umbilical cords. Basically, three quick disconnects that are held in place by a, how's it called, locking pin, because they're like spring-loaded, and once the locking pin is out, it will like disconnect quickly. Um, and we have three of them because we have two for pressurization, one for the fuel pressurization and one for the ox pressurization, and then one for oxidizer filling. So there's three quick disconnects, and there's a fourth umbilical, which is the electrical umbilical, which is a more or less with like spring pogo pins for electrical connection and held in by a magnet. And this will disconnect while the rocket lifts off. It's just like being pulled away by the rocket moving away. Okay, you see, most of the people have vacated the area. I don't actually see anyone there. Is it? Oh, there's someone in the back. Okay, no, it's still Max there in the back and Michi as well. Okay, so we're probably preparing for Oxidizer filling right now. Yeah, we haven't opened the bottles yet, but we are opening. You see now the bottom valve that just went blue. That's the oxidizer vent valve. So we opened that right up. This is part of the oxidizer filling procedure. So we're currently going through the motions and basically preparing the system for the pad crew, the final two people, to actually open the oxidizer bottles. Hopefully there will be no leaks. And once that is done, the pad crew will vacate the area, and at that point the entire oxidizer filling procedure will be remote controlled. Okay, apparently our oxidizer filling prep has been taking a bit too long, so we've been bumped to the later slots in the launch window. We're still go for launching this window though, so it's just a minor detour. Okay, so to explain a bit more, this is like a big event, and we have five rockets in our launch window, including us, so four other rockets. And because apparently our the launch window is only 1 hour, and we took a bit too long for the oxidizer prep, and the other rockets are all solid rockets and not liquid, so they can launch rather quickly. So they're trying to get the other rockets out the window first, and then basically it's back to our time. So we're only a detour of a few minutes, hopefully. We'll see how fast the others launch and how fast they come down again. So probably it's going to be around 16:40 local time, so 20 more minutes. But we shall see. Rockets are hard, you know? I'm not entirely sure which exact sensors you mean, Milo, but I think you mean the tank sensors that we used to have in the Straubing launch, and we basically decided that we don't really need them, and we wanted to reduce the complexity for this launch because, as you know, it's quite a hectic environment, and with other themes and everything, we wanted to reduce the likelihood of anything going wrong as much as possible. So that's why, if you've seen a few of the other stuff we've done before, unfortunately most of those were like internal streams and not public ones. Basically, the PNAD, the one thing you see to the right, the piping and instrumentation diagram, was a bit more filled back then, simply because we had more sensors in there. We've reduced it a bit, so hopefully less can go wrong. Okay, the first rocket in our launch window, the others just launched, and apparently successful launch, and they got a drogue. And you probably hear the tapping in the background unless the noise reduction is better than I think it is. Yeah, very happy for them. I don't know actually, was it BME? Okay,
Suborbitals.
BME suborbitals just launched, and they had a successful flight
700 meter downrange.
with their solid rocket engine. So very happy for them. Okay, so I've had a short chat with one of the pad crew, had to return after, like they can't be at the launch pads when the other rockets are launching, obviously. And apparently the turbo servos, both of them, have died, which is very suspicious considering that they're on their own CAN bus. So most likely the CAN bus died, which could be to a weak connection or like just some like contact, uh, to a loose connection basically. Um, and they're currently preparing materials for basically fixing this. So whenever the launchpad is free for us to go there again, they will just run there as quickly as they can.
Flight team is go.
Okay, and the next rocket for the solids is also go. So
Tracking go.
Yeah. And we try to just replug all of the CAN buses that this might be on, and hope for the best that this will
LC go.
hopefully fix it. Okay, the second rocket in our launch window has also successfully launched right now. We haven't seen any parachutes yet, so I don't know if it's still going up, but we haven't gotten confirmation of drogue, so maybe they're going down. While we're waiting for the other rockets to launch and
Altitude
getting ready.
1,200 meter.
Okay, and apparently they're on parachutes, so their launch was successful. Very happy for them as well. Let's go quickly through a few of the things for µHoubolt for our rocket. So basically, we're bi-liquid. We're the only liquid rockets on EuRoC. Very unfortunate. We would have loved to see Densta and Portal Space here as well and have a chat with them, but unfortunately they couldn't make it. So unfortunately, we are the only ones here. But yeah, we're using ethanol, like 96% bioethanol, I think it was, or 94%, something along those lines, and nitrous oxide, or laughing gas if you want to call it like that, and both in liquid phase. And we have a 900 milliliter tank of ethanol and 2.7 liters of nitrous oxide, with like pretty much all of the stuff completely built and designed in-house. The only things that we didn't do are basically the valves, though some of them we modified, and the, I think, oh yeah, right, and the body tube we didn't do ourselves, and we didn't manufacture the aluminum tanks ourselves. We did design them ourselves, but we thought we probably should have the tanks like done by a professional. We expect about 600 newtons of thrust at launch. We have a burn duration of 8 seconds until we just burn out, until we run out of fuel essentially. And we expect to reach an altitude of 3
Altitude
kilometers.
is about 300 meter. The team confirmed that this is the main chute. It's descending about 10 meters a second.
Okay.
Rocket is now 9 o'clock from Tribuna.
And in the background you probably heard that the announcer just said that Leofly, who just launched, are on 300 meters altitude on their main chute. So they apparently had a successful, like fully successful flight. Very happy, very happy. Yeah, what else is there to say? We have a very light rocket.
Downrange
We are
1,700 meter.
13 kilograms full if we are fully loaded and tanked.
Touchdown.
With 9 kilograms. Let's give them applause. Okay, with about 9 kilograms of empty mass, which I think is the lightest and smallest rocket on EuRoC. I'm not entirely sure, but we're at least pretty much, we're in the lower ones. Let's say it like that.
But I think fully fueled we're the second lightest.
Oh, okay, yeah. So we're pretty light. Apart from that, we have a ground support equipment, obviously, because we have liquids that we have to tank, which is remote controlled, and we have an internal flight computer that basically opens the engine, and that's it. I guess that's pretty much the most important stuff. Basically, we have a delay because 2 of our valves have randomly decided to disconnect. So unfortunately, we've had to basically delay our launch until after the other launched in our launch window, because we are not the only ones here. So the 4 other rockets will launch first, and then it's our turn again, and we will try to reconnect the valves, which is likely due to a fail in the CAN bus, the data bus that we use to connect to talk to the valves. And the next rocket is ready to launch, and we're hearing the goes in the background. You're pretty much right. We fuel the ethanol. Basically, we have a manual valve below the fin can, so it's happening before we mount the fin can. It's like literally a tire valve.
1,800 meter.
And basically, we just have a giant syringe with, I think, 1 point something liters of volume, and we fill it with 950 milliliters of ethanol, and just have a bit left over because we only have 900 milliliters in the tank. And then we just connect it to the tire valve, screw it in, and then push. And that's pretty much it. So basically before oxidizer filling, because we don't need to have a pressure regulation system for the ethanol because it's liquid at room temperature and pressure, which is convenient. So we don't need to pressurize it or something, so we can just do it manually.
However, that sounds very easy now. So pushing is really hard.
Yeah, pushing is really
in that
hard.
case.
The tank is almost airtight. We only have two tiny bleed valves, which are actually nozzles from 3D printers. And these bleed valves are basically there to provide safety in the case of complete loss of connection and control if we are already pressurized. So there's some way to relieve the pressure without us interacting with it, but it takes quite a long time to do so. And basically when filling the ethanol, you have to push all the air in the tank through this tiny 3D printer nozzle. So you have to like really give it, and it takes a while to actually get it full. But it's, all things considered, rather easy and quick. I think it takes about 5 to 10 minutes, depending on how hard you can push. Is an infection?
How does bleed work?
Yeah, the bleed wells are actually always open. They're like literally just holes in the tanks basically, and they're just tiny, so we just accept it. Basically, I think someone calculated once, if we are fully pressurized, it takes literally hours to go, like, to fully depressurize
Altitude
just
900
through bleed
meter.
valves. It's literally just a safety, so it can't, there is some way to get rid of the pressure if we have no control at all. And if the pressure rises quickly or more quickly than it can relieve, for example with the nitrous oxide, if more boils off than can bleed away through the valve, we do still have other passive systems like a burst disc, and I think we also have an overpressure needle valve or something. Yeah, that are set to way below the proof test and way below the calculated burst test pressure for the tanks. So we should all be fine. Okay, so we've just heard there's one more launch before us, and we have extension of the launch window. So hopefully we'll have enough time for actually getting a launch. Once the last rocket
Operation
is
waiting for
either
a touchdown
aborted
before we
or
can
scrapped
move, the operation
or
to
successfully
team number
launched,
15 higher.
we will like run over to the pad and try to fix our servos. And once that is done, I think we are like we have to run away of course again. This will take a few minutes, but the technical
300
part
meter.
should only be a few minutes if everything goes smoothly, which hopefully it does, because many mortar failures we can't really take, at least today. If we don't get off the pad, we will obviously try another day. And LeoFly just had successful touchdown on the main chute, so very happy for them as well. We have one more other solid rocket to go, and then it's our time again. I've been given a very important task by
Hi, teams,
one of
control
our
go.
one of our team members. I should give greetings to the µHoubolt from Flo. So
Tracking go.
if you're out there, feel greeted. Okay, unfortunately, the last team had to perform an abort, though fortunately this means that it's our turn now. They're probably going to save the rockets, and we will be able to hopefully run to the pads and fix our problems, and if that goes well, it should only be a few more minutes. Once all problems are fixed. Oh yeah, right. Launch window being extended. We've got information. Let's quickly fix this. We have estimated launch window is from 16 to 18 now. We got a full extra hour. We don't hope to use it. I don't want to say we don't expect to use it. Technically, once we get a connection to our valves, it's only a few more minutes. We just have to clear the pads and get the clearances, do the oxidizer filling, get clearance for oxidizer filling, do the oxidizer filling, and then it's off to the races. Though it will probably take a bit more than just a few minutes because launchpad is 600 meters away and we have to actually run over there, fix our problems, and then run back and only then start with oxidizer filling. So with all these estimates include like 5 to 10 minutes of sprint. Okay, I shouldn't have set the precedent. We're not greeting any more people, so everyone who has a family member or friends here at the launch pad or mission control or anywhere, feel greeted.
And very appreciated.
And very appreciated. So we're currently waiting for the last solid rocket to be disarmed, and once it's disarmed, we will run over there. Okay, our pet troubleshooting group is on the way. English are on the way, and hopefully they'll be able to find the error quickly. Our current estimate is that just the bus disconnected, and we basically lost connection to the two servos, which means that we just check for loose connections and replug the stuff in, and hopefully we will get connection back. The thing to look out for is if the servos that are next to the nitrogen bottle, indicated by N, if those get new sensor values. You see right now they're stuck at close to 512 and close to 60, if I'm reading this right. It's very hard to read on these monitors in the sun. But these are the ones that are disconnected and we're not getting any data from anymore. And once these are reconnected, the pad crew can basically continue with the oxidizer prep, which is, I think, just opening the oxidizer bottle and checking for leaks, and opening the pressure bottle and checking for leaks. And once that is done and we're leak free, which we hopefully are, we should be like 10 more minutes with running back and tanking, and then it's just launch clearance. Okay, so I've updated the bottom text, and of course it's not centered anymore, so bear with me while I realign it. Wonderful. Okay, so to get back, what is the target apogee? We're going for 3 kilometers with 600 newtons and 13 kilograms of launch weight. And yeah, liquid engine, so it's more interesting and more prone to failures. So yeah, we don't have 4 tanks, which means that it's 2 stages. We have 4 tanks because 2 of the tanks are pressurizing the other 2. So we have 1 oxidizer tank and 1 fuel tank, and those are like fuel is stored at atmospheric pressure, just 1 bar, and the oxidizer is tanked at 30 bar, 40 bar,
50.
40, 50?
50 and then 40.
Right, yeah,
50
yeah.
and dynamic pressure 40.
Yeah. And then we go after that and we pressurize our upper tanks with nitrogen, which is a pressurant. And this basically helps us push out everything and keep a constant pressure for the entire duration of the flight. So it's not just blowdown, but we have like a pressure, pressurized blowdown basically.
Yeah.
So the 4 tanks are not for stage separation, so there's no stage separation, we're only 1 stage. The 4 tanks are for fuel ox, and then 1 each for pressurization. Okay, so pet crew currently has arrived and they are working on fixing the problem. I can't really tell on the cameras what exactly they're doing because mostly that I can't see on the screens. Uh, yeah, I don't know. So we'll tell you more once we find out what happened. Just got a very good point from myself on stream. We could probably explain a bit what our engine and especially the nozzle and combustion chamber, how they work. On larger engines, you usually have like liquid cooling or like film cooling, regenerative cooling, with different kinds of basically making sure that the combustion chamber doesn't kill itself while firing. But for smaller engines, all of these options are not really economical or viable for like it's just too small to actually work well, or just too or at all, or just too hard to manufacture. So we chose an ablative combustion chamber and nozzle. So basically, during the firing, we have a phenolic resin with like a backing. I think it's just like paper or something. Yeah. It's a cotton. Okay. Yeah. So phenolic resin with cotton, which is rather temperature resistant, and when burning, it actually converts to graphite, right? It carbonizes and gets converted to graphite, which carries the heat away with it. So basically, it's slowly burning away inside, which basically shields the rest of the combustion chamber from the temperature. And this means that we can only like use them once, and we can only fire for a certain amount of time. But this is not really an issue for us because we own in our fuel tanks anyways, so we can't do like super long burn durations anyways. And swapping out the liner isn't all that hard. So it's a very nice compromise between ease of use and ease of manufacturing and price and reliability. Yeah, that's pretty much it.
And we have a quite low combustion chamber pressure of 15 bar, which means that the opening of the throat, so during the fire duration, the throat expands in its diameter of about, I think, 8 millimeters.
It was 8 millimeters and 4 millimeters radius, yeah.
Which should
Leo
usually
flight
would
confirmation control.
largely
Leo flight
affect
confirmation control
the
immediately.
thrust. But in our cases, we have a very low
Yeah.
pressure chamber. It doesn't really affect the thrust, and we have
Yeah.
nearly the full thrust, even at 3 km apogee.
Yeah. I think we dropped to about from 600 initial to I think 530 or something, and that's with pressure drop in the tanks and the nozzle ablating away, so it's really not all that much. And we seem to have our servos back. Yeah, we have movement on the pressure and venting valve, and the other one is giving us values as well. So I think we're good to continue. Let's remove that awful bottom overlay then. Yes! I just heard a scream from mission control that it's working again. So, yeah, I think we're good to continue. So now we're basically doing our pressure oxidizer filling procedure. We're doing the preparation first, so we check if our pressurant and oxidizer system are tight, so they don't leak. And once that is done, the pad crew will vacate the premises, and we basically start tanking. Unfortunately, I didn't get any more info right now. I've seen the connection to the electronics be disconnected regularly. Presumably, they're trying to find a permanent fix for the issue they found, but I don't really know. It might be that they're disconnected again and they're still searching. And I could probably ask them, but I really don't want to disturb them right now because this is a very high stress situation. And while streaming is really nice, and I love that we're able to share this with every one of you watching, it's really, really, really the second priority in this. Launching is definitely the first priority. So whenever they get time and we get information about that, I'll let you know. But for now, it seems they're still either fixing something or finding the fix. So if you have any questions, I think this is the last moment that we'll be able to actually get to them. So yeah, ask away in the chat and I'll see what I can do to answer. What software we're using? We're using our ECUI, or Engine Control User Interface, which is basically self-made. So yeah, it's basically our entire software stack is more or less in 3 layers. So we have our firmware in C++ on microcontrollers. It's STM, ST microelectronics microcontrollers. And then we have a server next to the launchpad, which runs an Ubuntu server instance, which basically has a low-level server which can interfaces with the microcontrollers, the firmware on the microcontrollers, and it also provides like logging to databases and a few other things like mapping and configurations. And then what you actually see to the right is our front end that we made ourselves. Like all of the software is completely self-made, which is pretty much just a website. So it's just like you connect to the local server that's next to the launchpad. We have a directed radio link there, like 2.4 gigahertz Wi-Fi antenna basically. And we just connect to the web server on the server next to the launchpad, and then we have a website that allows us to interact with everything. We seem to have the turbo servers back online. I don't know if it's temporary and they're just testing their fix, or if they finished the fix. Thanks, Ben, for the kind words. It's been quite the ride to actually make the system work. Like I've been the guy mostly making the front end. So all of the visual niceties you see to the right are basically my fault and or achievement, depending on how you want to see it. It's been a long time, and man, I really hope to see this rocket fly. Oh, Nicholas, we're actually planning to open source the entire rocket design and software after we finish with everything. So hopefully within the next few weeks to months, depending on how long we take to finish the documentation, hopefully our software will also be open source. We shall see.
Short update, we just tested the hold down circle and everything is fine and we are now ready to open the bottles.
Very, very cool. So, unless something else catastrophic happens, which of course it wouldn't, we should be able to continue with checklist and tanking. Yeah, I can't tell for sure what it is because mission control is a bit too far away, but I'm hearing them going through checklists. So we are going forwards. Let's actually quickly go back to the other screen so you can see the rocket unpacked. There we are. Now you see on the rail the white rocket to the left. The umbilical is unfortunately a bit covering it, but it should be still visible. I think they're currently opening the Oxidizer bottle, so I guess we'll switch back to our PNID so we can see actually what's going on. And please, all the love for the guys in the long sleeve shirts and long trousers in the, albeit 70-30 afternoon sun, it's still very hot and I'm sure they're actively dying out there on the pad. Apparently we are not tight. We had a pretty large leak and I couldn't quite tell where, and unfortunately it was on the other screen, so I can't say for sure. I'll keep you posted. Currently seeing water tanks to be refilled because apparently we may have lost something on the way, either evaporation or some minor leak. Or of course just pumping more water into the water mantle just drops the level, of course. Okay, so apparently over the long wait on the pad, our nitrous oxide bottle got a bit too warm. Not critically so, but this meant that the vapor pressure was a bit too high and the safety valve opened up. And this is the leak that we saw. Unfortunately, we were on the wrong cameras for that, so you didn't see it. So we're currently putting more dry ice in to cool the bottle down, which would reduce the vapor pressure as well, which allows us to start filling. So I presume it will still be a bit because it's a lot of water that needs to be cooled down and a lot of metal that's also like a thermal mass, but fingers crossed that it's not too much. That's what we get for including safety valves. And so apparently we are trying to open the bottle again carefully and with the finger on closing it again. And hopefully they've already put enough dry ice back into the water tank and cooled it down enough for it to work. Fingers doubly, triply, all crossed, everything.
Yeah.
So we've actually been able to open the bottle and oh, we actually have pressure. We actually are holding pressure right now. I just wanted to say that apparently we somewhere have a leak because we don't hold the pressure at all, but okay, yeah, we're still leaking, we're still dropping pressure, unless, now we are still dropping pressure, but it's not a catastrophic leak like before, it's not safety valve. So probably it's just tightening one more thing and hopefully it's good. Okay, so unfortunately, apparently, we do have to screw up. Apparently, the safety valve on the nitrous oxide bottle has frozen and probably not in a closed position, but even if it's not in a, if it would be in a closed position, it's just not safe enough to use. So I guess we'll try another day. So yeah, I guess if you still have any last questions, that's something we could address, but let's actually switch back to another overview. Um, yeah, if you have any other questions that we can still address, then ask away. Apart from that, I don't know. We'll try another day. We still have a few days of launch windows to go, and yeah, I guess I'll go back to the intro and everything, and yeah, that's it.
Nitrous or nitric ox?
It's nitrous oxide. I may have used them wrongly. It's a bit hard on the, you know, German to English terms to get them right. It's nitrous oxide laughing gas. So it's not pressurized air. It's the N2O, I think it is, the chemical formula. It's this. Actually, I think we're in the wrong camera. Let's go to that one. That's better. Yeah, this one is better. Yeah, so very unfortunate. Ultimately, it was probably just too much time on the launch pads. The nitrous oxide bottle just got too warm, and the safety valve releasing, while obviously making it safer, kind of messed it up. But I mean, you live, you learn. We never had to be in Portugal for a launch, and we never had to have a, like, I think almost 4 hours on pads. It's just a new environment, and we got to work with that. Yeah, okay. We will be calling it a day.
Thanks for hanging in with us.
Yeah. And
Attention all,
Oh.
attention. We would like the recovery teams to immediately report to mission.
okay, yeah, recovery.
Keep in mind we're a bit outside of the planned window, so we don't have that much time to perform
Yeah.
the recovery operation, so let's be efficient.
Yeah, so we have to get out of the sun, and we have to help packing the stuff. So this is it for now. I think tomorrow will be the next opportunity. We shall see. We shall see.
We'll keep you updated.
Yeah, we'll try to be a bit better on the social media posts beforehand, and not like, oh shit, we forgot to post on Twitter. So yeah, until then, and see you around.